All right, guys, in this video, we are going to wrap up the section 3.4. In the last video, we talked about just the basics of logarithms, but I wanted to bring in a few more things here, talking about common log and natural log. So the common log is when you have a logarithm with base 10. The natural log is when we have a logarithm with base e, and we have special ways to write them both. Common log is, if it's base 10, you can write it with no base at all, and it automatically implies that the base is 10, okay? Natural log, if it's a log base e, another way to write it is just to say ln of ln of x, instead of base e. You can just say ln, this stands for natural log, okay? And we're seeing these basic properties of log x and ln of x. So a common log and our natural log, they are the exact same properties that you guys saw in the last video. If you watched that one, when we found the properties of just basic properties of logarithms, it is the exact same properties, but this is specifically tailored to the common and natural logs. And we're going to practice using those real quick in this example below. No, we are not going to use a calculator yet. We will in a few moments, but we cannot depend on calculators at all times. So just make sure you're staying with me on how we do things without calculators sometimes, okay? All right, so we're going to go through this example 3, and we're going to follow those properties. Now, you're going to see me also rewrite some of these just until we get used to it, because I think that is helpful. What we have here, example 3, we are going to find log of 100. Okay, but what I need us to remember is what logs actually are when they don't have the base written. This is a log base 10, right? We don't see that, but it is implied as a common log. And I'm not going to write that every single time always, but every once in a while, it's nice to write it to remind you. Now, 100, we can actually write this to be 10, right, to the second power. And then we see that property where these guys match, and my answer is just the exponent. You could also look at it as we did log of 10 right here, right? Or log of 10 to the y, log of 10 to the 2. My answer is just that exponent 2. Okay? Let's look at this one over here. Log, and then it's square root, no, fifth root. Sorry, that's a fifth root of 10. This is log. Again, you can write the base if you want. And then I want to write this as my fraction. Remember, fifth root, we can do that as 1 over 5, which means my answer is just 1 over 5. Look at part C. This is log and 1 over 1,000. So really this is log base 10. And then 1 over 1,000, guys, we could write this as 1 over 10 cubed, but that's not good enough. I don't want that to be a fraction if I want to simplify my log. So really I should write this as log base 10 of 10 to the negative 3. That negative power drops it to the denominator. So my answer is simply negative 3. All right, and then one more over here. We have that last property where we were able just to cancel things out. Your answer is just 6. Yeah. Let's look at some of these with the natural logs. So you'd see these natural logs in part, or example 3. Same deal though. I mean, it's the same exact stuff. You just see the notation looks a little weird because you don't see the word log anymore. You just see ln. Okay. But we're going to work through that real quick. So we've got the natural log here. This is again log of base e. But follow the properties for the natural log. Okay. If it helps, you can write log base e if you really want to. But I'm going to try to get out. I'm trying not to get in the habit of that. So I'm going to write this as e to the 1/2 power because that is a square root. And then we have, again, when we have ln of e to the y is your answer. This is ln of e to the 1/2. 1/2 is my answer. Look at f. ln of e to the 5, the answer is just 5. Like here, e to the ln of 4, that's like your last property here. Your answer is just 4. So a lot of these, the properties allow you to make shortcuts and not have to work out a whole lot, okay? Which is a really, really, really nice thing. Now, we're going to get to the point where I'm going to ask you guys to actually use a calculator sometimes. Because if I ask you to calculate a logarithm and it is a decimal or a fraction, then that makes it way harder to do by hand, and I'm not going to ask you to do that. We are just going to calculate them with a calculator at that point. Your calculators are programmed automatically so that when you write a log in the calculator, they use log base 10. So that's an important thing to keep in mind. So let's make sure that we can all find this on the screen. Here, let me fix my settings. Forgot to change them before we got started. So on your calculation screen, okay, what we're going to do is we're going to find the log buttons. Now your natural log and your log buttons, you should see them right there underneath the alpha and underneath your variable buttons, okay? You'll be able to access those. So natural log and log. And again, these use just the automatic base E and base 10. So if I wanted to calculate log of 34.5, guys, the answer, it's just whatever you type in the calculator and get the answer up. We are going to round to 3 decimal places because our AP test is going to ask us to do it that way. Okay. Remember, I make these videos for all the classes, not just on level or just AP, but we're going to keep that consistent. So here we're going to do log in your calculator of 34.5, enter, and the answer is just 1.538-ish. We round that to 3 decimals. All right, do the same thing on the next one. We're going to say log 0.43, negative 3.67, negative 0.367. All right, now this next one's actually kind of interesting, and I want to talk about this one some, okay? If I do log of negative 3, this is not giving me an answer. I don't know if you can see that very well on the screen. Y'all see how it says non-real? Here's why, okay? When you calculate a log, you are asking about what is, what is the answer if I took 10 to some power? How could I get a negative 3 out of that? Okay, remember the base is 10. So 10 to what power is negative 3? You can't do that. 10 to any power is going to be a positive number. Even if you raise it to a negative power, it becomes a fraction, so it doesn't become negative. This is not real. Okay? So you got to look out for those. We're going to do natural log. Again, you just got to make sure you hit the right button, but really it's just type it in the calculator, see what it says. Okay? These are using E as the base, but remember you're going to use that ln button, natural log, 23.5. Okay. And my answer here is 3.157-ish. Okay. The next one, if I do natural log of 0.48, okay, we get negative 0.734. And we're going to have a similar situation here, guys. What we're dealing with when I find this is I'm asking what power, if I raise e to what power, how do I get negative 5? Guys, if you type this in, it's also going to tell you non-real. It's not a real number. Okay? Okay. we're going to now talk about solving real quick. I'm going to try to get through this kind of quick because I do need to go home for the day. But on this next one, we're going to practice solving a logarithmic equation. And this is going to take that skill that we've talked about with changing to exponential form. And we're going to be able to use that to help me solve an exponential equation. Okay? So we're going to go through that pattern. If you need to pull those notes back out, feel free to do that. But remember that what we have here is the base of my log is 10. So what I'm going to do here is I'm going to change it to exponential form. So we would have 10 raised to the third power equals x. Remember, the base of that log was 10. So the base of my exponential is 10. A log is equal to an exponent. So that is the exponent of my exponential. And that x will go over on this other side. Well, 10 to the third power is 1,000. So that's my answer. Or this guy over here, do the same thing. 2 to the fifth power equals x. Your base to this power equals x. Well, 2 to the fifth power is 32. That's your answer. All right? So again, these don't have to be that complicated. We feel like logarithms sound like they're this big, huge thing that's super complicated, but it's just not the case. Now, you might run into a few more problems with being able to do the transformation type of things. So let's talk about that for just a moment. However, you guys are pretty solid with transformations usually, so maybe this will be super easy for you too. It's going to meet the same kind of pattern we typically have. If you add or subtract a number inside the parentheses with x, that is a horizontal shift. It's always opposite the way that it looks. So if you look here at a, it's like they've taken the natural log function, so we're transforming that natural log function, and then they decided to move that to the left 2 units. So we're going to say shift the y equals ln x. We're going to say that we're shifting it left 2. All right. Whereas on part B, look what's happening. This one is added outside of the log. Right? Now we are moving, we're shifting the y equals, oh my goodness, I keep doing that weird thing. Log of x, we're shifting that common log, but this is going up 1. C is where it gets a little weird. I want you to notice something. These numbers are switched compared to what we normally think we should have, right? Typically, we like to see x plus a number or x minus a number, and that's not what you're seeing. What we're seeing is 3 minus x. So some of y'all may be able to kind of guess at what's going to happen here, but it's a little bit tricky and it's a little bit different than you might anticipate. So let's talk about it. Okay, this is where things get a little bit odd. All right, let's manipulate it a little bit. So I'm going to rewrite this as ln, but look at here. I'm going to factor out a negative. This would make this a negative 3 plus x. Well, why is that nice? Well, look here. Negative, this is x minus 3. Do you see that? Now, this reflection is happening to this whole part. So what we need to consider is that reflection is going to happen first. We're going to say reflect. We're reflecting y equals ln of x across the x-axis. Okay? And then we're going to move to the right 3. So we're going to say shift right 3. Okay, but that reflection is happening to that whole thing right there. So that's going to happen first and then the shift. All right, guys, we are going to split this up one more time and put a third video because this next thing is something that it may take a little bit longer, and I have to get out the door today, honestly. So I'm going to put this last question in our last video, part C. And so definitely make sure that you watch out for that if you miss it in class. All right, and I will see you in the next one. Bye.